continue looking at sequences, and in particular sums of sequences in today's video, and some summation notation. So if we have some sequence an, we define the terms an is some function of the term number n. Okay, that's how we've been defining sequences. Well, that's how we will for the purposes of this video. Now we're going to introduce a notation called sigma, and it's capital sigma. And if we take sigma from n equals 1 up to k of an, then that's equal to a1 plus a2 all the way up to ak. So the point is, this is a sum from this bottom number up to the top number of this function, and the different values of the sequence and the different values the sequence takes when we're changing n, starting from 1 up to k, increasing in increments of 1, of course. And we'll see some technicalities about how we have to be careful with the labeling here, and some rules we'll look at in a minute. First, we're just going to do a quick example. So if we take xn to be 2n plus 1, okay? Now if we sum from n equals 1 to 3 of xn, well, that's equal to x1 plus x2 plus x3. So x1's just 2 times 1 plus 1, x2 is 2 times 2 plus 1, x3 is 2 times 3 plus 1. So this turns out to be 3 plus 5 plus 7, and that's equal to 15. Okay, and that's fine because we only have 3 terms to add up. But say we picked our k, that top number is 17. I mean, this would be a little bit of a pain to calculate. There are some nice rules for this because it does turn out to be an arithmetic sequence, but we're not going to look at that in this video. So those standard results we're going to introduce are, we'll just shut this off for now. Let's do some standard results. First one, and these standard results are listed using R, which is fine, and R up to n. And so if we sum from r equals 1 to n, well, what does this actually mean? This function here, independent of r, so r is 1, r equals 2, r equals 3 until we get to n, that's what we're adding. But whatever r is, 1 is still 1. So we're just adding 1 plus 1 plus 1, and we're doing this n times. So this is just equal to n. Okay, so that's a nice result. Secondly, and this is not on the formula sheet, I believe, so it's important to remember, whereas the later ones are. But this isn't either, but that's pretty simple to remember. So from r equals 1 up to n of r, well, this is just the sum of the natural numbers up to n, isn't it? So this is equal to 1 plus 2 plus 3 all the way up to n. And why is this? Well, because r just takes whatever value this sum is. So r is going from 1 up to n by increments of 1, so that's just 1, 2, 3, 4, so on. And this is equal to 1/2 n multiplied by n plus 1. Okay, so it's important to remember these two results. Next one is the sum of the squares of the natural numbers. Okay, so that's equal to 1 squared plus 2 squared plus 3 squared plus 4 squared. Turns out to be equal to 1/6 n plus 1 2n plus 1. And then finally we have the sum of the cubes, and I believe the sum of the squares and the cubes are in the formula booklet, but I'll be sure to double check that. 1/4 n squared n plus 1. So you can see how these are nice and convenient, because whatever value we pick n for these particular sums of sequences, we can just plug that in and get the result instantly. We don't have to add up 90, 100, 150 terms, you know. What's also nice about this is sometimes we can write our other sums of sequences in terms of these results. So we'll see that now with our earlier example. So we'll return to the case where x to the n is equal to 2n plus 1. And we want to write this sum again, and I want to find an explicit formula from n equals 1 to k for any k of this xn. So that's equal to the sum from n equals 1 to k of 2n plus 1. Well, one nice property of the sums of sequences is we can take out the constant term, so we can take out the 2 n equals 1 to k of n, and we can separate out addition. We can do the sum from n equals 1 to k of 1 separately. Okay, so I moved the 1 over first, then took the 2 out of this expression. So that's perfectly fine, and now we can see this is in terms of our standard result. We know the sum from n equals 1 of n up to k. Well, that's going to be equal to, we find this result here. Bear in mind, n was our top number here, so we're not going to have n. K is our top number now. So that's equal to 2 multiplied by 1/2 k, k plus 1. So that's just k, k plus 1. Now our sum from n equals 1 up to k of 1, well, that's just 1 added to itself, k times, that's just k. Now we can take out k, and if we take out k, we get k plus 1 plus 1 inside the bracket, so that's k plus 2. Okay, so now for our sequence at xn, whichever value we pick k, we can just find the value of the sum using this formula. And let's just check it. If we take k equals to 3, we get 3 times 3 plus 2 is equal to 3 times 5, that's equal to 15. And that's what we wanted. Okay, so hopefully you can understand this summation notation now. The next video on sequences for A-level maths, we are going to look at arithmetic sequences. So hopefully you come back for that. If you've got any questions, let me know down in the comments, and I hope to see you in the next one.